Hello, good afternoon to hello afternoon. I am Professor Ankita Tiwari from SIRTE Excellence College, and today I am representing my topic, that is search techniques in data structure. So what is searching? Searching is the process of determining whether or not a given value exists in a data structure or a storage media. Searching algorithms are designed to check for an element or retrieve element from any data structure where it is stored. So searching broadly classified into two categories. First is linear search and second is binary search. So first we will discuss by linear search. We discuss two searching methods, okay? And one-dimensional array, linear search, and the binary search. An array is a data structure with same data type that contain a series of elements. The element of array can be identified by the using its index value. So the index value always start from the zeroth value. The linear or sequential search algorithm on the array is sequential scan of the array, comparing each array item with the search values. If match is found, the return index of the matched element, otherwise return -1. No, not linear search can be applied to both sorted and unsorted array. Okay, so linear search is a very simple search algorithm. In this type of search, a sequential search is made up of over all item one by one. Every item in the checked, and if a match is found, then the particular item is returned. Otherwise, the search continued till the end of the data collection. So this is the example of linear search where we found the number 20, value is 20, and the structure of data elements is 10, 50, 30, 70, 80, 60, 20, 90, 40. So we will start searching from the first position, that is index position 0. So first we compare with the search element 20 with 10, then 20 with 50, then 20 with 30, then 10, 20 with 70. So always the result will not found, not found. And after that, it's at sixth position, the element is found. And the element is search element and the index search element and the array element is same. So there is the it will return the position number 6 where the your element is found. If element is not found, that is the worst case, and if element is found at last index position, that is the worst case. If element is found at first value, that is the best case. If element is found in middle of the array, that is the average case. So this is the simple algorithm of linear search where some steps of linear search. It is the representation and the algorithm implementation with the help of example how the algorithm is work, which is already I told you. This is a program of linear search in C++. Now the complexity of linear search. In linear search, best case complexity is order of 1, where the element is found at the first index. As already I am told you, if element is found at first position, this is the best case. Worst case complexity is order of n, where the element is found at the last index or element is not present in the array, as I already told you. And after that, we are moving towards binary search. Binary search uses a recursive method to search an array to find a specific value. The array must be sorted array. Okay. Binary search will apply only in a sorted array. Okay. That means the elements are arranged in the increasing order. If the value is found, the index is written as a linear search. If the value is not found, it will return -1. Note, each execution of recursive method reduce the search space by about a half. So what is the basic procedure of binary search? A binary search is an advanced type of search algorithm that find and fetch data from a sorted list of items. Its core working principle involve dividing the data in the list of half until the required value is located. and displayed to the user in search result. Binary search is a commonly known as a half interval search or the long term search. So there is some steps of binary search. Find a middle element. First of all, we position all the element, then find the middle element of the sorted list, compare the search element with the middle element in the sorted list. If both match, then display given element is found and terminate the function. If both are not matched, then check whether the search element is smaller or larger than the middle element. If the search element is smaller than middle element, then repeat step 2, 3, 4, 5 for the left sublist of the middle element. If the search element is larger than middle element, to repeat 2, 3, 4, 5 for the right sublist of the middle element. Repeat the same process until we find the search element in the list or until the sublist contain only one element. Okay. And the last, if that element also doesn't match with the search element, then display element is not found in the list and terminate the function. This is the procedure of binary search. Basic conceptual diagram of binary search, how it is work. So from this diagram, you can find your answer with iterations. There is some iteration. In first iteration, we find a mid value, and second iteration, we find the sub array, and third iteration, we also find mid value in the sub array, again sub array, and fourth iteration, again we find the value of mid. And if our element is mid value, then it will return a mid. If our value is lower than mid value, then we search element in the lower in a left sub array. If your element is greater than mid value, then you will search your element in a right sub array. Okay, so this is the general description of binary search. This is the description of this diagram. You can understand from this diagram. If the value look for that larger than the value in the middle, the value array segment. This is a pseudocode for the binary search to locate the value first greater than last. यदि आपकी value first की value आपकी last से बड़ी है, then you will enter in the algorithm else mid approximate midpoint. If key equals to a mid, if your value is mid, then return mid, that is your the search element. Else, as already you told you, if key is less than a mid, then return the result search key of first through mid minus 1. Else if key is greater than a mid, then you will call the second subarray. This is the recursive method of binary search, in which if your element is if your array list is divided in two subarray, so first position is always first, mid minus 1 is your last element in a left subarray, and mid plus 1 is the first element for the right subarray. This is the checking search method. Why do we need a binary search? Binary search work efficiently on sorted data, no matter the size of the data. Instead of performing the search by going through the data in the sequence, the binary algorithm randomly accesses the data to find the required element. This makes the search cycle shorter and more accurate. Binary search perform comparison of sorted data based on a ordering principle, then using equality comparison, which are slower and mostly inaccurate. After every cycle of search, the algorithm divides the size of the array into half. Hence, in the next iteration, it will work only in the remaining half of the array. Efficiency of how to calculate efficiency of binary search. So the binary search algorithm extremely fast compared to an algorithm that try all the array element in order. About half of the array is eliminated because if your element is greater, then you will search on the right subarray. If your element is smaller, you will search on the left subarray. So your half of the array, almost half of the array is eliminated. So this is the efficiency because in the linear search, you will search all the element in the last position. But in the binary search, you will you will enumerate the searching in by eliminating searching by the find of with the help of mid value, then a quarter of the array, the eighth of the array, and the so forth. So given array with 1,000 element, the binary search will only need to compare about 10 array element to the key value. So as compared to average of 500 for a serial search algorithm, the binary search algorithm have a worst case running time that is logarithmic order of log n. A serial search algorithm is linear order of n. If desired, the recursive version of the method search can be converted into an iterative version that will run more efficiently. This is the iterative approach of the binary search. Binary search is divided in two approach, iterative and recursive. In iterative approach, you will mention the loop or conditions, and in recursive approach, we use the recursive function call. Thank you.